section 4.3 is the quadratic functions and their graphs properties. So we are going to explore everything we can about the quadratic equations, right? The functions. So we are going to graph using transformations, which is a concept that we have covered in the previous sections. We are going to identify the vertex and axis of symmetry from the given quadratic function. We are going to graph using vertex, axis, and intercepts. Then we are going to find the equation given the vertex and another point. And we're going to do max or min value of the quadratic function from using an application. Okay. So first, the quadratic function. So it is in the form f of x 8x squared plus bx plus c. What tells me that it's a quadratic function? That we're dealing with a quadratic is that the highest exponent is 2. So that automatically tells me that I am dealing with a quadratic. Now this is the standard form of a quadratic. Let me get my thing set up. So this is the standard form of a quadratic, right? Now you also have what is called the vertex form. So it looks something like this. And the vertex form, I want you to think about it. So somewhere back in the days, let me make this pen a little bit skinnier. Somewhere back in the days when you were in Algebra 1, you were introduced to y equals mx plus b, right? So whenever you needed to graph a linear function, the best was to have it in y equals mx plus b, because when it's in this form, you're able to see that the m is your slope and that the b is your y-intercept, right? Now, the standard form of the linear function is 8x plus by equals c. When it's in standard form, it's not easy for us to just determine the slope and the y-intercept without doing any work. The same applies for the quadratic function. When it's in standard form, it's not easy for us to see the transformations that happen for us to graph them. But when it's in vertex form, we are able to see what is the vertex. We're able to see what is the y. It's easier to identify the y-intercept. We're able to see when it goes up, when it goes down, if it goes to the left or to the right, whether it's wide or narrow, whether it has reflection among the x-axis or the y-axis. We're able to see all those things when it's in vertex form. Okay, so when it's in vertex form, it's something like this. So it is your responsibility to know the difference between which form. When it's in standard form, what is the process that you need to do in order to graph it, in order to determine the vertex, the axis of symmetry, and all that information. Then when it's in the vertex form, what each component of it means. And we learned in some sections before how to go from the standard form to the vertex form. All right, so let's see. So you have this, it's your parabola, right? Oh, why is it so thick? I need to change it. So we have x squared, okay? This point right here, this is your min, or if it's this way, your max. This is also your vertex. So the vertex is the point HK, okay? So it's an X and a Y. It's the max or the lowest point of your parabola, okay? So we refer to the quadratic function as a parabola. When it's looking up, it is concave up, okay? When it's, oh, my face is in the middle right here. Okay, my bad. When it's looking down, let me see if I can move it. Get the pointer. Okay, I got the pointer. No. Can I move my face? Let me see if I can move this face. Yay, I am moved. Did it move everywhere? Hopefully it doesn't move in the other parts. Okay, so when it's looking down, so it opens up, meaning the A, the number that goes right here for the A is less than 0. So now this is opening down, so it's concave down. All right. That vertical line that splits the parabola in half, it's called the axis of symmetry. And the axis of symmetry is x equals h. So that comes from the vertex, the x value of the vertex. It is a vertical line. So anytime you're asked to determine the axis of symmetry, know that it's an equation. So x equals a number. All right. Let me see in my notes right here if there's anything else that I was supposed to share. Well, axis of symmetry, concave up, the domain of a parabola, we know is all real numbers, and the range will depend on where whether it's opening up or opening down, and where the min or max are at. Okay, so let's see an example. And this example comes directly from your homework. So we have given f of x equals x squared minus 6x plus a. Find the following. Find the vertex. Write your answer as an ordered pair. The equation of the axis of symmetry, whether this is concave up or concave down. We need to find the intercepts. So this is talking about the x and the y intercepts. We need to graph the function. We need to find the domain and range. Determine when the function is increasing, decreasing. And we need to determine when the function is greater than 0 and when it's less than 0. Okay, so let's first start. Let me go ahead and write it down. Okay, so we have, oh, this needs to be a little thicker now. So we have f of x equals, I already forgot, x squared minus 6x. And again, I already forgotten, plus 8. All right, so the first thing that we need to find is the vertex. In order to find the vertex, when the quadratic is in standard form, as you can see, this is in standard form, we are going to use this formula. So it says to find the x, it is negative b over 2a. Now from your quadratic, I know that a is 1, b is negative 6, and c is 8. So then I'm just going to substitute those values in here. So then I have 6 over 2 gets me 3, right? If I make any mistakes, it's sad because you won't be able to tell me because this is not live. All right, the second part of the vertex, we need to identify the y. So the y is take what you found for x and evaluate the function. So when x is 3, what is the y? So I am simply going to substitute that in here. So I have 9 minus, what is that, 18 plus 8. So what is that? So that is negative 1, is it? Let's double check again. So I have negative 9 plus an 8 gives me negative 1. Hopefully that is correct. So my vertex, and I am writing kind of big. I have for A, I have 3, and for Y, I have negative 1. So this is the vertex. And then the next question is, what is the axis of symmetry? So the axis of symmetry is the x value. So the equation, it is the x value of the vertex. So that is x equals 3. That is the axis of symmetry. And then let's see what is the next question. Is the parabola concave up or concave down? Based on the A, which is a positive number, the parabola is concave up. Okay. What else? find the intercept. So we're going to do that in another page because we're not going to have that much space. So we know that it's concave up. We know that the vertex is this. We know that the axis of symmetry equation is this as well. Okay, so we need to find the intercept. So I'm just going to rewrite my parabola here. Plus a, right? Yes. Okay, so if I am looking for the, I'm going to start with the y-intercept. I usually start with the x-intercept, but I'm going to start with the y-intercept. So if I'm looking for the y-intercept, I am going to substitute 0 for the x. Okay, so that gives me that. So I know when x is 0, the y is 8. So the y-intercept is the point 0, 8. Now, if I am looking for the x-intercept, I am going to substitute 0 for the x, for the y, and I know that f of x is my y, so this becomes 0 equals x squared minus 6x plus 8. So then here it's where you have to make sure you think about, all right, out of everything that I have learned so far, what method can I use in order to solve this quadratic? One of the shortest ways, I will say, is to try to factor. So factors of a that will add to 6, I do believe that is 4 and 2. So this quadratic, I am able to factor it. So I have x and x minus 4 and 2. Now I am solving for x, so I'm going to set each set of parentheses equal to 0 and solve. So I have x equals 4, x equals 2. So I have 4, 0, and 2, 0. Those are my x-intercepts. Okay? So this is my y-intercept and my 2x-intercept. And I solve this by factoring. Okay. So now let's go back to what is the next question. Graph the function. So now we're going to go ahead and graph this. And I didn't get myself a coordinate, but we're going to do that. The best, let me see. I think I might be able to just go ahead and add a small coordinate plane if I have. I don't think I have one. Oh, no, that is not the best. Okay, we're just gonna do one from scratchy. Okay, so I'm just going. My problem is I don't do straight lines. That is my problem. Look at that. 1, 2, 3, 4, 5, 6, 7, 8. I cannot make straight lines. I even with a ruler, even when I have a oh, that looks bad. Even when I have a ruler, my lines are not straight. Even with a ruler. And that's just everywhere because even when I walk, I don't walk straight. I like stumble to the sides. And then running also struggle with that too. But I just want you to know when you're taking this note, you do the very best graph you can. Okay, let's write down everything that we know. I don't know if this green here will be good. Let's do this blue. Maybe blue and blue won't be so good. Let's see. Oh, no, not bad. Ooh, this is looking nice. It's like aqua blue. Okay, so my vertex is 3, -1. 3, -1. My y-intercept is 0, 8. I'm just putting all the information here so we know in order to graph. My x-intercepts, we had the point 4, 0 and 2, 0. we know that it's going to concave up, and now you know that the axis of symmetry is x equals 3. Okay, so first thing we're going to graph is my y-intercept. So I have 1, 2, 3, 4, 5, 6, 7, 8. Then I am going to graph my x-intercept. So I have 1, 2, 3, 4. 1, 2, 4, and 8. Ooh, 5, 6, 7, 8. Okay, and we know that our vertex is 3, negative 1. 1, 2, 3. 1, 2, 3, 3. 1, 2, 3, negative 1 right here. Okay. That looks bad. Wait a minute. Are we doing something wrong? Yes. Yes, we did. I did something wrong because it's 2, 0. Okay, so how did I know that I must have put a point wrong? This right here. Because if my vertex is 3, negative 1, and I had a y-intercept, an x-intercept right here, how is it that I was going to have another one over here? That was not going to looking up like this nicely. So 2, 0 right here. Now that makes so much sense. All right. So now that I am going to go ahead and graph, again, my graph is not going to look very nice because, okay, let's do that one again. Okay, so I know this is going to go like this. Oh, oh! I didn't want it to go so much, but when you're graphing in your homework, make sure you do it correctly. If I wanted to know a little bit more about what's happening on this side, like how wide or narrow my graph is, always and always you are able to do a table of values. All right. Okay, so next question. Find the domain and range. So we know that the domain is from negative infinity to positive infinity because we know it's all real numbers as it expanding from the negative side to the positive side. All right. For the range, if I go from the negatives to the top, I start touching the graph exactly at negative 1 for the y. And the arrows are going to keep going and keep going, and that's going to go all the way to positive infinity. All right. And then it wants to know the increasing and decreasing. All right. So with increasing and decreasing, you are always going to read from left to right. And what you're asking yourself is, what is happening to the y as I am going from the left to the right? As I am going from the left to the right, so as I am going from the left to the right, the y values are decreasing, okay? So it's decreasing, okay, from negative infinity all the way to 3, okay? And then it's increasing from 3 all the way to positive infinity. Okay, so again, what is happening to the y values as I go from the negative infinity to the positive? So as I go from the left to the right. Okay, the next question is where is the function greater than 0? And then where is the function less than 0? So f of x is greater than 0 from, so where are the y's positive? Everything above the x-axis. So the y's are positive from negative infinity. What is that, 2? Yes, 2. Okay. Union from 4 to positive infinity. And then where is the function less than 0? Well, what is below the x-axis? So that will be from 2 to 4. So this question right here, where is the function above the x-axis? okay? And then this question right here, where is the function below the x-axis? Okay, so below the x-axis is just right here in this interval, okay? From 2 to 4. Now, when it's greater, everything above. And you need the union because you need to connect this and this right here, all right? So that was one example. And we answer all these questions.